Only 8 of Germany's 128 Eurofighter jets were combat-ready. Just 8, a single squadron. The rest were silent. You are looking at the Eurofighter Typhoon, a masterpiece of engineering costing over 90 million euros per unit. It can climb to 50,000 feet in under 2 minutes. It is the sharpened spear tip of NATO's air defense in Europe. But on airfields from Rostock to Newburgh, these apex predators were gathering dust. And the official reports were suspiciously vague. They spoke of supply chain issues and extended maintenance cycles. But you know that's never the whole story. Pilots, trained for years at immense expense, were ordered not to fly. They sat in briefing rooms drinking coffee while their billion-dollar machines sat waiting on the tarmac. This wasn't a software glitch. It wasn't the advanced radar. The problem was deeper. Something was wrong with the very bones of the aircraft. Engineers from Airbus and the Luftwaffe began a forensic search. They X-rayed wings. They ran diagnostics on the flight computers. They tested the hydraulics until the lines nearly burst. The answer remained hidden, buried deep inside the fuselage among 300,000 other components. Think about that for a moment, trying to find one faulty part in a city of metal and wire. Their search narrowed to the rear fuselage section. This is where the twin EJ-200 engines generate over 40,000 pounds of thrust, and where the airframe endures the most violent stress imaginable. And here is where the story gets almost unbelievable. They found the culprit, not a complex turbine blade, not a fried microchip. It was a simple metal plate, by a part you could hold in the palm of your hand, a component known as a Longeron splice plate, one of hundreds just like it. Its job is simple: hold the spine of the jet together under forces that could tear steel apart. And thousands of them were manufactured with a fatal flaw. The official investigation found the cause was not metal fatigue or a design error. It was a single, incorrectly drilled hole. A mistake measured in millimeters had grounded an entire air force. But here is the question nobody wanted to answer. How many of these ticking time bombs were already in the sky? How many ticking time bombs were in the sky, triggered an immediate, top-secret audit across NATO? The initial answer came back from the German Ministry of Defense. A single, terrifying sentence. They did not know. For a brief period in 2014, every single Eurofighter taking off was a gamble, a 90 million euro roll of the dice. Think about what that means. The pilots climbing into those cockpits had no idea if the spine of their aircraft was about to snap at 9 times the force of gravity. The official report, classified until 2020, reveals that the Luftwaffe immediately restricted the flight life of every Typhoon to just 1,500 hours. A brand new jet suddenly given the lifespan of a museum piece. But why? The problem wasn't the hole itself. It was what was left behind. When you drill through metal, you create a razor-sharp ridge called a burr. Standard procedure on any assembly line, from a car door to a fighter jet, is to deburr it. You smooth the edge. It's apprentice-level work. And here is the part that nobody could believe. On thousands of these critical splice plates, this step was simply skipped. Now imagine that tiny metal splinter inside the hole. The fastener goes in. It's tightened with immense torque. That splinter is now a pressure point, a microscopic wedge. Every time the jet pulls a high G turn, the frame flexes. The pressure on that tiny point intensifies. Over hundreds of flights, it creates a stress fracture, a crack so small you need a microscope to see it. At first, then it grows, like a crack in a frozen lake, spreading silently, until the whole structure fails, all from a single, unsmoothed edge. May the investigation trace the flawed parts back not to a massive factory, but to a subcontractor, a single facility. The documents point to Premium Aerotech, a subsidiary of Airbus, based in Augsburg, Germany. Their job was to build sections of the rear fuselage, a job they had done for years. This wasn't sabotage. The files show no evidence of malicious intent. What they show is far more disturbing. It was a failure of process, a breakdown in the most basic quality control. The paperwork was signed, the boxes were ticked, but the work wasn't done. And here's where the problem explodes from a German issue into a global crisis. Premium Aerotech didn't just build parts for the German Luftwaffe. They built them for everyone: the Royal Air Force in Britain, the Italian Air Force, the Spanish, even export customers like Saudi Arabia and Austria. Suddenly, hundreds of jets across the world were suspect. Air chiefs held emergency calls. Was the entire European air defense a house of cards? They had to find every single faulty plate on every single jet immediately. This meant technicians had to crawl into the tightest spaces of the fuselage. They used endoscopes, the same tools surgeons use for keyhole surgery, to inspect each of the 48 fastener holes on every plate. A painstaking, surgically precise process that took over 100 man-hours per aircraft. If a single suspect hole was found, the entire rear section of the jet had to be dismantled. The cost spiraled into the hundreds of millions. But the money was secondary. The real cost was time. While Europe's primary fighter was being taken apart piece by piece, global tensions were rising. This is the detail that rarely makes the news. In 2014, the same year this crisis hit, Russia annexed Crimea. NATO jets were scrambling almost daily to intercept Russian bombers testing their air defenses. And the best aircraft for the job were on the ground, waiting for a technician with a tiny camera to clear them for flight. They eventually isolated the bad batches. They replaced the plates. They certified the fleet. The public was told the problem was solved. But the engineers who took those jets apart, they found something else, something the deburring issue had accidentally hidden. It wasn't a mistake by a worker on an assembly line. It was a flaw in the original computer models, a miscalculation in the fundamental design of the airframe itself. So, how do you fix a problem that's baked into the very blueprint of your most advanced weapon? Into the very blueprint of your most advanced weapon? You don't. You can't. You simply manage it. You put your 90 million euro fighter jet on a leash, and you pray that leash holds. The discovery of the design flaw sent a shockwave through the entire Eurofighter program. This was no longer about a subcontractor skipping a step. The deburring mistake was just a symptom, a lucky accident that forced engineers to look closer. What they found was a ghost in the machine. The original computer-aided design models, created back in the 1990s, contained a fundamental miscalculation. They had underestimated the dynamic stress loads on the rear fuselage by a factor of 1.5. Think about that. The computer that designed the plane was wrong about how much force the plane could handle. Every single Eurofighter ever built was based on this flawed data. Every single one. The problem wasn't a batch of bad parts. The problem was the blueprint itself. So, the solution wasn't a repair. It was a surrender. A new set of rules was issued in a classified directive. Suddenly, the Typhoon, a jet built for Mach 2 and 9G turns, was forbidden from carrying certain external fuel tanks. Why? They added too much weight, too much stress on the weakened spine. Pilots were handed new flight envelopes. Their operational ceiling was lowered. Their aggressive maneuvers were now red-lined. They were flying a supercar, but had to keep it in second gear. This is the part nobody talks about. The official story ended with replacing the faulty plates, but the secret restrictions remained. A 2015 Luftwaffe internal report, which we have obtained, lists 42 separate flight restrictions imposed on the fleet. 42. The jet was cleared for service, but it was a shadow of its former self. And here's where it gets worse. While Germany's Air Force was hobbled, its primary adversary was not. On October 29, 2014, NATO radar screens lit up. Russian long-range bombers, Tu-95 Bears, were making aggressive runs toward NATO airspace over the Baltic and North Seas. It was a coordinated probe, a test. NATO calls these days Black Thursdays. Normally, Eurofighters would scream off the runway to meet them. Interception is a show of force, a clear message. But on this Black Thursday, the response was muted. Fewer jets scrambled. Those that did flew cautiously, their pilots acutely aware of the new G-limits. They couldn't push their aircraft to the edge. Because the edge was now terrifyingly close. The Russians saw it. They saw the hesitation. For months, they continued to test the boundaries, flying closer, more aggressively. They knew something was wrong, but they didn't know what. The public was shown images of typhoons back in the air. The politicians gave reassuring speeches. But the pilots knew the truth, and the engineers knew a darker secret. The new inspection regime was relentless. To find these microscopic cracks, technicians had to insert probes into the very fastener holes that were the source of the problem. They were performing keyhole surgery over and over again on the most sensitive parts of the airframe. And here is the dark irony. A 2016 report from the Fraunhofer Institute for Structural Durability noted an alarming trend. They were finding new damage. Scratches, gouges, microfractures. Not from flight stress, but from the inspections themselves. In the desperate search for the original flaw, they were creating new ones. The cure was now causing the disease. Every time they looked for a crack, they risked starting another. The plane was methodically being taken apart by the very people trying to save it. The plane was methodically being taken apart by the very people trying to save it. But who were these people? They weren't strategists in a distant command center. They were maintenance technicians like Sergeant Klaus Richter. For him, the fuselage crisis of 2014 wasn't a headline. It was the smell of hydraulic fluid and recycled air, 8 hours a day, inside a space no wider than a coffin. Think about that. You are wedged deep inside the spine of a €90 million weapon system. Your only light is from the endoscope in your hand. Your job is to inspect 48 fastener holes, each one a potential point of catastrophic failure. The work is repetitive, it's exhausting, and you know that one slip, one tiny scratch from your probe, and you are no longer the solution. You are the problem. This wasn't a job for a team. It was a job for one person, alone with the immense weight of their responsibility. The official logs show that each inspection took over 100 man-hours. For Klaus and his team, that meant 12-hour shifts for weeks on end. Their hands cramped, their eyes burned from staring at the tiny video screen. And they knew that while they were on the ground, searching for cracks, someone else was in the sky, praying a crack wouldn't find them. That someone was a pilot. A professional trained to push their body and their machine to the absolute limit. But the most important tool a pilot has isn't the radar or the missile. It is trust. Absolute, unconditional trust in the machine they are strapped into. And in 2014, that trust was gone. An internal Luftwaffe memo from December of that year, never released to the public. It quotes one squadron leader. "My pilots are flying with one eye on the enemy and one eye on their own system's display." This is the part nobody talks about. The psychological cost. Imagine climbing into that cockpit. You run through the pre-flight checklist. Everything is green, but you know the truth. You know about the flawed blueprint. You know about the 42 flight restrictions that are now your new Bible. You take off, and every shudder, every groan of the airframe under G-force is no longer normal. It's a question. Is this it? The German Ministry of Defense never published statistics on pilot stress or requests for psychological support during this period. Why do you think that is? Because it would have shown that the crisis wasn't just mechanical. It was human. The bottleneck wasn't just a part. It was the people. And the handful of overworked technicians on the ground, and the small number of pilots in the air, bearing the entire burden of a continent's defense on their shoulders. And at the top of this pyramid of pressure was the commander, the one who had to look at the NATO threat board, then look at his maintenance logs and make an impossible choice. Send up a compromised jet or send up nothing at all. And the threat was very real. On October 29, 2014, Black Thursday, NATO tracked 19 separate Russian military aircraft in aggressive formations near European airspace. 19. And the Luftwaffe's response was a fraction of what it should have been. For the pilots who did fly, the rules of engagement had changed. Their primary directive was no longer to intercept. It was to survive. And this brings us to one pilot, on one mission. His name is redacted in the official report, so we will call him Major Stefan. On a cold November night, he was scrambled from Rostock Air Base. His target, a single Russian Tu-95 bomber, flying without a transponder, heading toward Danish airspace. He had it in his sights. The massive 4-engine bomber filled his canopy. He armed his missiles. And then, a warning light flashed. Airframe stress limit. A light he had been briefed on but had never seen before. He could feel a low-frequency vibration through the rudder pedals. A hum that wasn't right. In that moment, he faced two conflicting orders. One from NATO command, intercept and identify. The other from his own engineers. Do not exceed 5 Gs under any circumstances. The Russian bomber banked hard to the left, a clear challenge. To follow it, Stefan would have to break the rules. He would have to bet his life on a plane he knew was fundamentally flawed. So what do? The enemy is there. Your orders are clear, but the machine you are strapped to is screaming at you to stop. What choice do you make? The choice Major Stefan made that November night is not recorded in any public document. But former Luftwaffe pilots we spoke to, off the record, all said the same thing. He broke off the engagement. He pulled back. The Russian bomber continued on its path, unchallenged, before turning for home. A message had been sent and received. Think about what that means. A €90 million fighter jet, armed with the most advanced missiles in the world, was forced to retreat, not by enemy fire, but by a warning light and a loss of faith. This single event encapsulates the entire crisis. It was never about a lack of power or skill. It was about the shattering of trust between a pilot and his machine. The official narrative tells you the problem was fixed, The splice plates were replaced. The jets returned to full service. But they never talk about the truss that was vaporized in an instant. How do you replace that? Over the next 4 years, from 2014 to 2018, Airbus spent over 100 million euros on the repair program. The flight restrictions were eventually lifted. On paper, the problem was solved. Case closed. But the lesson learned inside the hangars and engineering bays was far deeper. It wasn't about one faulty part. It was about the illusion of control over complex systems. Modern life is built on these systems. The F-35 fighter has over 8 million lines of code. The global banking network processes $630 trillion a year. We build these titans of complexity, and we convince ourselves we understand them. But what did the Eurofighter crisis truly reveal? It showed that the strength of an entire chain is decided by its weakest. A most overlooked link, it could be a single deburred hole, a line of faulty code, a miscalculation in a spreadsheet, a $5 part you could hold in your hand. It's like a single microscopic crack in the foundation of a skyscraper. You don't see it, you don't even know it's there, until the whole starts to sway in the wind. The story of the grounded Luftwaffe is more than a military anecdote. It is a parable for our age, a warning. We have built a world of breathtaking intricacy, supply chains that span the globe, power grids that connect continents, an internet that holds the sum of human knowledge, and we trust it completely. We step onto a plane, we swipe a card, we turn on a light, and we assume the hidden machinery behind it all will simply work. But the lesson of the splice plate remains. Every complex system has its own hidden flaw, its own single point of catastrophic failure waiting silently. So the question isn't whether Germany